Hello everyone. So our next topic is electric potential due to a dipole at any point in xy coordinate. So how to find potential due to dipole? So we'll cover the derivation part and even the numerical part. Okay, so moving forward. Okay, so again revising the basics that due to a charge q at distance r, suppose there is a point P. So potential at point P will be kq by r. So k into charge divided by at what distance the charge is being placed. So at any point the potential depends on the charge and the distance between the charge and the point. So potential is basically kq by r and value of k is 9 into 10 raised to power 9. We have a complete lecture on this formula, how we derive this formula. You can view that lecture in the 12th class playlist. Okay, so this formula is very important. So moving forward, you have to remember this formula. Okay, so what is a dipole? So an electric dipole is basically a system in which there are two charges, that is minus q and plus q, and there's a separation of 2a between them. So basically there are two charges minus q and plus q placed at a distance 2a from each other. So distance between minus q and q is 2a, and this is the midpoint. So this is a and this is a, and I have to find potential at a point P which is at a distance r from center of dipole. So this is center and the point P is at a distance r from center of dipole, and the angle between this r vector and dipole moment is basically theta. Okay, so the angle between r and dipole moment is what? Theta. So I have to find potential at point P, total electric potential at point P. Suppose point P is at a distance r1 from q and at a distance r2 from minus q. So potential at point P can be written as kq by r1, because from q the point P is at a distance r1, so kq by r1, and from minus q the point P is at a distance r2, so minus kq by r2. So taking kq common, so in the bracket by taking LCM we'll get r2 minus r1 divided by r1 r2. So our next aim is to find r2 minus r1 and r1 r2. So suppose that point P is at a distance r, and this distance r is much greater than a. So basically the value of r is much more than a. So r1 and r2 can be written equivalent to be equal to r. So r1 into r2 will be equal to r square, and after this line, after this perpendicular, both r2 and r1 will be same. So r2 is more than r1 by this distance. What distance? See, this is 2a. So this is basically 2a. If this angle is theta, this will be theta, because we can treat r2, r and r1 to be parallel, because the distance between the two charges is very small in comparison to the distance r. So r2, r and r1 can be considered parallel. So if this is theta, then this will be theta. So this is 2a and this is theta. So the component of 2a near to theta will be 2a cos theta. So r2 is more than r1 by a distance of 2a cos theta. So r2 minus r1 can be written to be equal to 2a cos theta. So r1 into r2 can be written as r square, and r2 minus r1 can be written as 2a cos theta. Okay, so putting the value of r1 and r2 and r2 minus r1, we'll get the formula k. r2 minus r1 can be written as 2a cos theta. So on the place of r2 minus r1 we have 2a cos theta, and on the place of r1 r2 we have r square. But dipole moment P is basically q into 2a. So q into 2a can be replaced by P. So basically potential at point P will be equal to kp cos theta divided by r square, and multiplying r on both numerator and denominator will get kpr cos theta divided by r cube, and pr cos theta can be written as p dot r. So potential at any general point due to an electric dipole can be written as k p dot r divided by r cube, where p is dipole moment, r is the vector joining the point and center of dipole, and this r is magnitude of r vector. So now coming to a numerical, suppose 2 coulomb charge is at minus 1 comma 0 and minus 2 coulomb charge is at 1 comma 0, and center of dipole is 0 comma 0, and you have to find potential at point P. Suppose point P has coordinates 100 comma 200. Now what will be the potential at P? So we'll start by first finding out P vector. So what is the dipole moment? So dipole moment is basically charge into distance between charge. So charge is 2 and distance between both the charge will be 1 plus 1, 2, and direction of dipole moment is from negative to positive. So direction from negative to positive, so it will come out to be minus I cap. So P vector is minus 4 I cap. How to find R vector? R is basically position vector of point minus position vector of center. So position vector of point is 100 I cap plus 200 j cap minus position vector of center. Center is 0 I cap plus 0 j cap. So R is basically 100 I cap plus 200 j cap. Now putting the formula of potential, the potential is basically K P dot R divided by R cube. We have K, we have P, we have R, and we have small r also. That is magnitude. So magnitude is basically root of 100 square plus 200 square, and putting all the values we'll have electric potential. So you have to remember this formula, and also you have to learn how to use this formula, because this formula has two parts. One is Kp cos theta by R square, another is Kp dot R by R cube. So if you have coordinates of charge and point, then you have to use this formula, the formula in which you have to use the vector form. And if you have angle, then you can use the another formula. Like how to use it in the next example. Suppose the question is find electric potential on any equatorial point of dipole. Suppose we have a dipole q minus q a, and this is the equatorial point. So dipole moment will be from negative to positive. So this is a dipole moment, and joining this point P with the center, we have R vector. If you'll see, the angle between R and P is theta is equal to pi by 2, and formula of potential is Kp cos theta by R square. So cos pi by 2 is 0, so potential at any equatorial point is 0. So you have to remember this line, that potential at any equatorial point of an electric dipole is equal to 0. Okay, now on the basis of this lecture, first you have to remember this derivation, and second you have to remember the formula. Both these things are very, very important. Now you have to submit an online quiz on the basis of this lecture. So then I'll see how much you have learned, and remember to write down this derivation, because the derivation is very, very important. Okay, bye bye. Thanks a lot.